Hello, everyone. My name is Zanie Blue, and I work at Astral building tools for Python developers. And today, I'll be talking about how agents use developer tools, what qualities of tools are important, and how the design of tools is changing as agentic programming grows. So briefly, what are developer tools? At their core, developer tools are abstractions that help with parts of the software development lifecycle. And this includes a lot of things, like issue trackers, programming languages, compilers, package managers, etc. Did I lose my microphone? No, it's good again. In this talk, I'll be focusing on the tools that agents interact with when writing code, rather than tools used for the entire software development lifecycle. That means tools that help with tasks like writing, inspecting, and running programs. So why are tools helpful for agents? Agents are open-ended systems. Unlike most of our tools that do one thing repeatedly, agents are generalized and stochastic. They need feedback to constrain their solutions. They get some of this feedback through their own chain of thought and through their harness, which might even include other agents giving feedback. However, to build reliable systems efficiently, we need deterministic and specialized feedback from tools. The most important outcome of feedback is correctness. If the agent's solution is incorrect, that's clearly going to have negative consequences. So how do we use tools to determine correctness? Well, first of all, you run the code. We usually call this testing. Ideally, we do this in a controlled, scoped, and reproducible way, which requires tooling. For example, a package manager, a test runner, a mocking library, a coverage analyzer. Another way that we can use feedback to inform correctness is static analysis. In this, we analyze the code itself rather than running it. This is generally faster than running the code, and it doesn't require writing tests. It can catch untested assumptions, and it can find edge cases that you haven't accounted for. The most familiar forms of this are type checkers and linters. Today, we have tools to do this because humans struggle to reason about it at scale, and agents really struggle with this too. There's a bunch of research showing that agents can't do complex static analysis, even if you do fine-tuning on those kinds of tasks. Aside from correctness, I want to talk about quality, which is another important trait that we can improve with feedback. This captures a lot of different elements, like what makes code good. Is it readable? Is it documented? Is it well factored? Are there vulnerabilities? Does it use deprecated APIs? Is there dead code? Is it fast? Is it performant? These have less short-term implications than correctness, but they're very important for the long-term success of projects. We also care about traits that aren't driven by feedback, like efficiency. For example, we care about how long it takes an agent to finish doing a task. Similar to humans, while an agent probably could solve a problem without a tool, for example, one of my coworkers complained that the agent used curl to download a wheel from PyAI directly and then unzipped it into their site packages. That's probably not the most efficient way to work. Not only does it take time to perform tasks that could perform faster by a tool, but it consumes valuable context. Tools can help agents be more efficient by specializing in solving subsets of problems better than an agent would with an ad hoc approach. We also care about safety. The open-ended nature of agents, as well as the inclusion of untrusted inputs, means that agents can perform undesirable and surprising actions. Tools are a key interaction point between agents and other systems, and while they can greatly empower agents, they can also be used to provide boundaries and constraints, for example, with fine-grained access controls and sandboxing. Another important one is that tools allow agents to learn more about the state of the world. The canonical example here is searching for context across many files using ripgrep, which is every agent's favorite tool, or looking up the documentation for a function. So those are all the qualities that I think are relevant when you're talking about a single agent interacting with a tool. But agents are inherently scalable in a way that people are not. You can quickly scale up to hundreds of agents and then down to zero again. And this means that there are higher order interactions between agents and tools. And we need to consider how tools interact with many agents. To help consider the consequences of this paradigm, imagine if all the problems faced by teams of 100+ engineers become problems commonplace for teams of 10 engineers. One change that's really apparent already is that agents are making it much easier to produce large quantities of code. They're dramatically increasing the amount of code in the world, and this means that tools designed for working at scale are going to grow in importance. Today, this isn't necessarily the bottleneck in most agentic loops because inference isn't very fast. However, inference is going to get faster, and tools will become the bottleneck. We're also seeing scaling problems with concurrency. People are using many agents in parallel and delegating work to agents in the background. Teams of agents are being used to coordinate on larger features, and people are increasingly context switching and supervising agents instead of focusing on a single task. An easy example of this changing tool use is that suddenly everyone is using Git worktrees, which I had not heard of 2 years ago. As agents scale, reproducibility is also important. For example, we need to be able to quickly construct developer environments for agents, and we need to be able to track changes to those environments and propagate them back and merge them together. A good example of this is using Terraform to manage infrastructure or enumerating your dependencies in a PyProject toml. Declarative environments increase the scope of what agents can effectively collaborate on. So next I want to take all these concepts and consider how they might affect our roadmap and tools. At Astral, we work on a few tools in the Python ecosystem. Hopefully you've heard of them. There's Ruff, a linter and formatter, TY, a type checker, and UV, a package and project manager. In some ways, I feel like our tools are really well positioned. They're designed to be fast, regardless of scale. They're built for declarative workflows, and they're robust to concurrent use. We expect to continue investing in those areas, but there are other places that we need to adjust our focus. First, I'll talk about tool output. Today, our default output targets humans, and agents honestly do pretty well with that. But there are many ways that we can optimize our output for agentic use cases. Output is the main way that our tools communicate feedback to agents. So what's the best way to communicate to an agent? Here's what a diagnostic looks like from TY, our type checker, today. I think it's beautiful, but I'm honestly not sure if it's the ideal diagnostic for an agent. Do they need all this context, or is that just redundant? Is that just eating into your context window? It's hard to guess. I think that to come to a conclusion here, we would actually have to do research assessing agent performance on different output formats because it's not immediately clear. Some decisions are easier. For example, we've been long considering a review mode for Ruff. This is a design that I wrote in 2023 when I first joined Astral. I was working on a Ruff CLI RFC for the future work. And a review mode here would allow you to interactively view each violation in your code, accept a fix, add a suppression, etc. in a TUI. But now interactive feedback feels like it would serve too few of our users, and I just don't think we'll end up working on this. Next, I want to talk about reducing context consumption in output for more efficient tool use. Machine-readable output is an obvious first step here, allowing the agent to compose with tools like JQ to access the subset of data that they need, so they're not eating into the context with each tool call. However, right now, using JSON output can actually increase verbosity. So this is a comparison between the default output of UV and the JSON output for UV sync when you're just validating that an environment is up to date. If we were installing packages, it wouldn't fit on the slide at all for the JSON output, so I couldn't use an example with that. Clearly, this isn't a context reduction on its own. The agent needs to actually subset the data. But how does the agent know what's available so it can pick out what it needs? If we were a tool that existed 10 years ago, it would be in the training set, but we're a new tool. If we're adding new JSON outputs in machine-readable formats, how do we teach agents about those? There are a few different approaches here. Here's one idea. we could just build context reduction into the tool itself. UV is best suited to decide which fields are important, and so instead of showing that whole JSON blob, we can show the things that we think are important and then allow the agent to opt in to fetching data from additional fields. A challenge with that, then, is that the agent needs to run the commands multiple times to get the output they need. The classic example here is the agent repeatedly tailing the output to get more logs while debugging, increasing the number each time. And while UV is really fast, like, not all commands are free to run repeatedly like that, and UV even has to do quite a bit of work on each of those operations, and that won't scale once you have hundreds of agents. A way to solve this is to persist the output and give the agent a pointer to a file instead. Then the agent is receiving reduced context by default, and it can always investigate further as needed. This is applicable beyond machine-readable output. For example, when something goes wrong, you need to run the command again with the verbose flag to get logs. We could just store those verbose logs in a file always, and then allow fetching them from that file afterwards. This exists in some tools today already. We've actually seen that and liked it and explored adding it to UV, but it hasn't felt critical until now. I want to move on to another roadmap item other than output. So I want to talk about language servers. Language servers, or LSPs, power a lot of human interaction with programming languages in editors. And we're pretty actively working on a language server in TY, our type checker, and we're finding there's a lot of uncertainty about how we should be prioritizing features. There are features like autocomplete that have a very large amount of engineering effort necessary to produce a good feature, but that don't really make sense for agentic consumers. These kind of features are feeling increasingly unimportant. There are other features that do feel valuable to agents, like when they need to modify a name or symbol across a bunch of files. The LSP can do that much more efficiently than it falling back to tools like sed. And there are human-facing features which still feel important today. For example, for code review, using go to definition or find all usages is still a really nice thing, but these kind of features aren't available in UIs like GitHub, or their implementation is not robust and does not rely on LSPs under the hood. So part of what we're noticing here is that the language server protocol isn't designed for agents. There's a bunch of stuff in there that's not relevant. And we may want to consider designing new protocols that are specifically for agents to understand the semantics of code. Another roadmap item, plugins. Historically, plugins have been low on our list of priorities despite being a very popular user request. They're hard to get right, and they require exposing internal concepts of our tools, which we're worried will slow us down. But now we might need to reassess that prioritization. The best way to get compounding benefits from agents is to have them build their own automations and feedback loops. Allowing the agent to extend their tools is a very powerful paradigm. For example, the agent could define custom lint rules to prevent itself from making future mistakes. This could be a form of memory for agents. I want to talk about confidence next, and here I'm talking about our own bar for confidence in what we're telling users. So our current bar for confidence in lint violations or warnings is very high. We would rather have false negatives than false positives because we don't want to overwhelm humans with diagnoses that may not be correct. However, agents don't have this problem. They won't get fatigued if they get too many diagnostics. We might want more low confidence lints that an agent can then assess whether or not they're applicable. Similarly, like Ruff has automatic fixes for lint rules, and those fixes generally guarantee that they won't change the semantics of your code. However, if you can have an agent assess whether or not a fix encounters one of the edge cases that we're worried about, but that are too challenging to statically encode in the tool itself, we might actually want to add a bunch more unsafe fixes to Ruff that the agent can apply and then assess after the fact. A good example of that is like a huge swath of fixes in Ruff are marked as unsafe right now because they might drop comments, which you can put in a stupid number of places in Python syntax, and there's a lot of ambiguity there. And like people are prevented from using those features because we're worried about a comment missing, but that's the kind of thing an agent would catch very easily. One more roadmap item I want to talk about is that our tools should have a different model of trust with agentic users. And this raises some questions about features we have, like the ability to ignore type errors. Should the escape hatches that we give humans exist in agentic harnesses? Like, should they be able to add no QAs? Should they be able to add suppressions, turn formatting off? Or do these just enable the agent to behave poorly? I think we should probably default to constraining them more. Another example is adding sandboxing to UV. I actually have a pull request up for this. Well, I pushed a commit, but it's AI slop, so I haven't opened the pull request yet. And this sandboxing makes like the tools that you run with UVX have reduced permissions. They can't access the file system outside the working directory, and they can't access secrets. This kind of lockdown functionality is useful to humans, but it's essential when you're working with agents. Sort of as a last roadmap item, I want to talk about expanding the scope of what we're working on. We're kind of considering everything here. For example, should we build a Python test runner that's focused on agentic users? Should we ensure that Python remains competitive with other languages that are becoming popular for agents, like Go? We could leverage TY to compile Python code and improve execution times. Should we invest in tooling outside of Python, like with Rust? We work with Rust a lot, and we work with Rust with agents, and it suffers from really slow feedback cycles because compile times are so slow. Or should we step back and continue to focus on the human developer experience, something that we're really passionate about? We could build higher level tooling that orchestrates agents. Is that within the scope of our company? It's hard to say. We're thinking about lots of things here. As a closing thought, I expect a lot of disruption in the space of developer tools. And something that keeps me up at night is the idea that not far down the line, the agents will just implement purpose-built tools that address their use cases. There's already research showing that agents that are allowed to construct their own tools for their harness outperform harnesses that have been pre-built by labs. I'm not sure if this will happen soon. I think that innovations in foundational developer tooling require deep insights and domain expertise that agents are not currently capable of. But it is this possibility that like maybe in a few years they'll just be modifying UV to do these things that they need, and they'll have a better job assessing within their training cycles and their fine-tuning what is actually optimal for them. Thank you very much.
Awesome, thank you very much. We have a few minutes before lunch. Any questions?
Thank you. So thinking about that last thought about agents writing their own tools got me thinking a little bit about composability. And so I'm wondering if you've given any thought to the idea of perhaps decomposing some of what UV and the rest of the suite give you into smaller pieces that agents could recombine in new ways so that they don't have to write their own tools as much as take those more discrete components and recombine them as necessary.
Yeah, I think that really ties into the idea of like plugins and extensions. I think it's not necessarily realistic for us to split UV into multiple smaller components. I think you would just end up like duplicating a lot of space with the repeated implementations that we share. But I think more touch points for integrating with UV. We're adding more commands that expose like UV's internals as machine-readable outputs so that people can build things that integrate with that. We're exploring like adding hooks to common touch points in the system so you can build those kinds of extensions. Yeah.
Well, it's in the same line of it's a question of like, how do you start having like the agent itself? Because you've talked about the increase in context that like the output of UV might create, but in a sense, like the agent is good at managing like maybe those outputs and creating an output that's proper for the actual agent doing the work. Like, is there like work on agent in the loop of the tool itself? So like not the one developing, but the one like a separate one, like a role specific or context specific that just deals with that. Like,
yeah, I haven't really considered that. I mean, of course, like there is an increasing trend of using like sub-agents to perform tasks to reduce context overhead by having them, do the task and then report an output. And I think that like if you took like this JSON output and you used a plugin or extension to UV to inject an agent in between that extracted what you needed, that's certainly a viable option. I think it's going to be a lot more expensive to run an agent to perform that kind of task when you could instead just like, pick out the subset of a machine-readable output. That's like sort of where the value of deterministic and specialized tools comes in, is that we can give you all the context that you need, and we can explain, like we can expose schemas, and you can tell the agent this is the schema, and it can choose what it needs without needing to have another agent like stochastically choose some subset that it might be relevant. But yeah, it's an interesting idea.
Awesome. Thank you so much. Another round of applause. And then